Hello again. This is the third video for the All About the Periodic Table series. Sorry, I'm just flipping through here to find where we left off here. Okay, so here's the periodic table, which is what we've been discussing and going over, and we talked about isotopes and all of those things. All right, and so now we're going to look at electron arrangement. So how do we arrange electrons of an atom into energy levels? So first, let's review here. Okay, so if we look at an atom, okay, hopefully by now all of you know that we have a nucleus. So here's our nucleus here that contains the neutrons and the protons. Okay, and our electrons reside in energy levels around the nucleus. Okay, and each of these energy levels has its own energy, and the electrons that are in these energy levels have the same energy. Okay, so we're just going to do energy levels out like this. Okay, so we have electrons that are in these energy levels. Okay, the energy level that is closest to the nucleus, we call this energy level N equals 1. So N just stands for energy level. Okay, and the second energy level away from the nucleus, N equals 2. Third, N equals 3. And N equals 4. Okay, so once again, N stands for the energy level. Okay, and so what we're going to do is we're going to look at the first 20 elements. We may not do every one, but hopefully you'll catch on as we go. But we can use the periodic table to help us arrange electrons in these energy levels for whichever element that we are wanting to find the arrangement for. Okay, the first thing we need to know before we can do this is that the first energy level, so N equals 1, holds 2. So it can only hold up to 2 electrons. Okay, so here's our electrons all around the nucleus there. Okay, N equals 2 can hold, if I can spell, hold up to 8. And N equals 3 can hold up to 8. Okay, and as we go out further, we'll see that N equals 4 holds up to 32, but we're not going to go this far for the purposes of your course. So we're only going to go up to the atomic number of 20, okay? All right, so now that we know this, what we want to do now is to relate our energy level to the periodic table, okay? And so whatever period we're in, okay, so we've learned that periods run from left to right or horizontal, okay? If we're in period 1, then this is equal to the energy level of 1. Okay, so period 1 on the periodic table is going to be N equals 1. Okay, so here's our first period going across here. Okay, our first energy level can only hold up to 2 electrons. Okay, so if we count over here, we've got 1 element and we've got 2. Okay, so in the first energy level for hydrogen, it's going to just have an arrangement of 1. It's got 1 electron because we see here we've got an atomic number of 1, which means we have 1 electron as well in a neutral atom. So our electron arrangement would be 1. Okay, for helium, so we moved over 1 to 2, we're going to have an arrangement of 2 in the first energy level. And then we would stop there because our N equals 1 corresponds to the first period, and there's only 2 elements there. And so conveniently for us, since the periodic table is designed so uniquely as well as so convenient for a chemist, it's also arranged according to the electron arrangement. So we can just count over and count our electrons. Okay, let's say for lithium, if we were going to come up with the electron arrangement for lithium, okay, you can't forget that we still have electrons in that first energy level. Okay, so remember we've got our energy levels going around. Okay, so for lithium, we've got 3 electrons. So we have to account for all 3. We can't just say lithium 1. Okay, we have to account for all 3. Okay, so we start back up here at the very top, and we would say our first energy level has 2, and we just put a comma there. And then our second energy level, we're only going to have 1. Okay, and so when you add up your numbers there, it should add up to 3, which is the number of electrons. Okay, so if we looked at, let's say, oxygen, it has 8 electrons. So our first energy level holds 2. So if we move from left to right, from top to bottom, just like you're reading a textbook, then you have to pass by each. So 1, 2. So that would be our first energy level. You come down to the second energy level. So here N is equal to 2. Okay, this would be our second energy level. And we move over. 1, 2, 3, 4, 5, 6. So oxygen's electron arrangement, so we're looking at electron arrangements, is going to be 2, 6. Okay, if we move over to neon, okay, it's still in the second energy level, but so we're going to have our first energy level is full, then we're going to move over 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Neon and our noble gases here in group 8, the reason that they are called noble gases and they're inert or they're stable is because their octet is full. Okay, meaning that their outer shell is full. It has 8, and we know that that energy level can only hold 8, and so it's full. It's stable. It's happy the way that it is. And what we're going to see is that other elements want to be like the noble gases. They want to gain or they want to lose electrons so they can be like these stable noble gases here. Okay, so let's move down to the third energy level, which corresponds to the 3 here. Okay, so let's do magnesium. Okay, if we were writing the electron arrangement for magnesium. Okay, we've got to start up top. So we would have 2 in our first energy level. If we move down, we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the second energy level is full for magnesium. And then if we move to the third energy level, so N equals 3, then we're going to have 1 and 2. Okay, for argon. So if we look at argon in the third energy level, okay, so move over here. Okay, it's going to be 2, 1, 2 in our first energy level. Move down to N equals 2, and we have 8. Okay, so we move all the way across, 1, 2, 3, 4, 5, 6, 7, and 8. Move down to the third energy level, 1, 2, 3, 4, 5, 6, 7, 8. 2, 8, and 8. Once again, argon is a noble gas, and it has a full octet, so its energy level is full. Okay, so its third energy level here would have 8 electrons in it. Okay, we're going to stop at 20, so let's go ahead and do calcium. Okay, after that, you start going into your transition elements and what we call d orbitals, and we end up with 32 electrons that fill this shell. So we're just going to stop at 20. Okay, so if we look at calcium, so if we move from left to right, our first energy level, we've got 2. Our second, we move all the way across, we've got 8. Third, we move all the way across, we have 8. And then we move over 2 for calcium. So in the fourth energy level, we have 2 electrons. Okay, another thing that we want to do is we want to practice. Okay, so if we, let's find some space here to practice. Okay, so I want you guys to come up with the electron arrangement. Let's see, let's do sulfur, chlorine, potassium, and aluminum. Okay, so if you want to pause this video, you can to work these out and then turn me back on. but we'll go ahead and start with these. All right, so sulfur. We have 16. If you look at your periodic table, you always want to have that handy. You look at 16. So we've got 16 protons, which means we have 16 electrons. So when we get done with our arrangement, we know that we have to have 16. It's got to add up to 16. Okay, so if we move across the periodic table, so let's go back here. There'll be a lot of flipping back and forth. We may lose my writing. Okay, so here's sulfur. Okay, so as we move across, okay, we're going to go past both of our electrons in the n equals 1, or our first period. Okay, so we've got 2. So better yet, let's erase here. Okay, so we've got sulfur here. Okay, so as we move from left to right, so we're moving along here, we're going to fill our first energy level. Okay, then we're going to move down to our second energy level, and if we move all the way across, we haven't gotten to sulfur yet, so our second energy level is full as well. Then we move down to our third energy level, n equals 3, and we move over 1, 2, 3, 4, 5, 6. So we have 6 electrons in the outer shell. We're also going to learn that the outer shell, so here's our outer shell, these are called valence electrons. Okay, and these are the most accessible electrons because they're in the outer shell. They're the furthest away from the nucleus, and they can react with other atoms, and they're just the more accessible electrons, and so they are involved in reactions. Okay, I forget what I told you guys to do next. I think it was chlorine, but that's really close here. So all we would have here, we would have 2, 8, and 7. Okay, so you want to go back and count everything up. So in sulfur, we have 14 plus 2, we've got 16, and we've got 17 electrons there for chlorine. Okay, I know one of them I said to do was aluminum, I believe. Okay, so if we found aluminum here, we've got to have 13 electrons. So we'd have 2 in the first shell, we have 8, move all the way across just like we're reading left to right. And then we'd have 1, 2, 3 in the third energy level. So aluminum would have 3 valence electrons. Okay, and I think I told you guys to do potassium in the fourth energy level there. So we've got 2 in the first, 8 in the second, 8 in the third, and then we've just got 1. So as we move across here, 2, all the way through 3, and then we're just on the first one for potassium. So if we add these up, we've got 19 electrons, and we have 19 here. This concludes the video on electron arrangement, and our next video will be on valence electrons and trends of the periodic table. Thank you.